Hello, I'm Sean Collins. I'm going to be speaking about Hanami today. This is great to follow up the last talk. If you guys are looking to learn something new, hopefully you can learn something new from this talk. So Hanami is a flexible framework for maintainable Ruby apps. And notice I didn't say that it's a web framework. It is primarily a web framework, but it's not only a web framework. And basically, it can provide a foundation for any kind of Ruby app, which brings me to my first point, which is that Hanami is modular on several levels. So Hanami itself, the framework, is broken up into component libraries. They're all wrapped together in this main Hanami gem, but each part can be swapped in or out as you choose. And also, your apps are modular. So there's a oops, sorry, that's the wrong button. Your apps are also modular, so you can have like slices of your app that are separated, so like the mini apps inside of your application, and so you can set it modular that way, and those are called slices. Hanami is also modular in that everything is wrapped in a module as a top namespace, so there's no classes that are defined in the global namespace, so it keeps everything nice and tidy. Hanami lets you write Ruby rather than a dialect. So some other Ruby web frameworks, you end up learning how to write this specific type of Ruby that's not really Ruby, but it's a dialect on top of Ruby. And before this talk, I just checked, and Active supports core extensions, the monkey patches in it. It adds 2,057 methods across 26 different classes. And I also created a new active record with just created that and updated that, no other attributes on it, and it was over 300 methods just for that. In addition to the methods that every Ruby class gets, like those 60 or whatever. So it just adds all that, and most likely you don't need all of that. And Hanami champions immutability and functional programming style. So rather than managing state in your inside of your classes and objects, Hanami prefers immutability, so it will give you a new copy of something rather than mutating the same thing. And I don't have time to go into why this is beneficial, but it does help you get rid of a bunch of bugs. And it also, in my experience, lessens your mental load a lot while you're programming, because you don't have to worry about managing state of these objects as you're programming. So I'm going to go through some of the libraries. So this is a gem. These are the names of the gems. And so Hanami is the main one, and that's like the full stack framework that encompasses everything else. And that includes like conventions for where to put your files, configuration, your slices, your containers, which we'll talk about later. There's also Hanami CLI, which I didn't put here, but that's the command line interface, so it has all the generators and all that, and that'll be merged into Hanami itself soon. We extracted it and we decided we want to put it back. There's Hanami router, which can be used again with any. It's a rack compatible router, so it can be used with any Ruby library. We're not going to cover Hanami router today. It's pretty straightforward. You can look into it yourself, but I just bolded the ones that we will go through today. Hanami controller is your action layer. So that's what takes your requests in, your params, your form params, and delegates out, and then can render a view, can render a view. And then we're also going to talk about Hanami view. And then there's also Hanami assets, which we won't get to today. There's Hanami DB as well, which is our database layer, which we will cover, which is based on ROM SQL. And also dry operation, which is part of the dry RB family. And so a lot of Hanami is built on the dry RB organization of gems, and also the ROM RB organization. And earlier this year, actually, like the Venn diagram of the contributors for those was almost a circle. It's like very, very tight. And earlier this year, we announced that we're going to merge them all into one called Hanakai, which means flower party. And that way, and we're going to have a new website this year. Oh, I forgot to mention I'm a core team member of Hanami and Hanakai. So we're going to do that later this year. And so some other gems that we're going to be using, or that are used in Hanami. These are not all of them. These are some of them are dry validation, which is probably the most common, is the most common one used in Rails apps. It gives you really nice, like very verbose, like articulate, I want to say, like everything's like defined out exactly like what the shape of your data is going to be. Dry system, which provides our containers, which we'll talk about later. Dry monads, which is part of dry operation, which is basically, in this case, all we're doing is just, our operations will either be success or failure, and that's what dry monads gives us. Dry struct, which is just our immutable data that we use in ROM SQL. Dry logger, which is what we use for logging. Dry configuration, use our configuration. Dry CLI is a general purpose library, like similar to Thor, and we use that, of course. And there's many more. These are just some of the big ones. Okay, so this is what MVC looks like in Rails, where it is a conceptualization of it. And one thing I want to say here is that there's 1 to 7 public methods here. And so actually it's kind of something more like this, where we have all, and obviously you can have more, but if you have all of the RESTful, resourceful routes, then you end up having like all these methods that don't necessarily have that much in common with each other, all in one class. And we'll, later on I'll show what the Hanami architecture looks like later. Okay, so in simple cases, MVC is enough. But in larger apps, some problems arise, right? Models get big, control actions get too long. You use an interactor or service object, but it's not really sanctioned. You can do it, but it's not really like the way that it's not encouraged. And everyone has their own way of doing it. Also, views in Rails are just templates. And so, you know, I think most people have moved away from using instance variables directly in templates, luckily. But that was just like, if you have like an instance variable nested into a partial, that gets very messy. And also there's just, the way you prepare your data is up to you. And so to fix that, we reach for some abstractions. One are our concerns, which are modules that are included in Rails. Also engines, which are isolated applications, which we'll talk about a little bit later. And then some other ones that people use are view rendering objects, so something like view component or flex. Also service objects or interactors. Again, everyone has their own one that they like. Some query objects, if you have really complicated queries, these are things people use. And then presenters or decorators. And so these first two are part of Rails, concerns and engines. And in my opinion, they're also like the worst two on here for various reasons. And yeah, so basically like with Hanami, we have these things included and we have slices, which are like engines. And we have like these types of things inside of the framework because they're common patterns that people run into anyway. So we decided to include them in the framework. Before I get into details of Hanami and how it's different than Rails, I want to share the story of how I discovered Hanami, which is 10 years ago. I just moved to Boulder, Colorado, and it was a couple months before Rocky Mountain Ruby. And Rocky Mountain Ruby was at Boulder Theater, which is just a couple blocks away, which is a very beautiful room if you haven't been. It was opened as an opera venue in 1906. If you want to check it out for yourself, and you happen to be a fan of amateur boxing, and you want to get some about Boulder's college feel, you know, tonight they have Fight Night, which includes fighters from Boulder's fraternities. So if you want to spend $38 to watch frat bros beat the crap out of each other, that's a great move. Okay, so at Rocky Mountain Ruby, I had only been doing Rails for a couple of years, and so I was trying to get as much information as I could, and I was starting to run into some of the issues with Rails and growing your application. And I took a workshop about Rails engines, which, like I said, are these like mini apps that you can mount inside of your Rails app. And I love the idea of it. It makes sense, just like break it up keeps the scope down, the complexity. It really it helps like narrow things down. And so it's a really elegant way to modularize your code base in theory. So who here has used Rails engines? Nice. Who here has had a great experience with Rails engines? Yeah. So I've done that. I tried 2 different projects like using Rails engines a lot, and they're just like really like it's not the Rails way, which as you probably know, you're gonna have pain every step of the way. Basically, like you have to copy your migrations over. Barely any Rails gems support engines, and so you'd have to like monkey patch that and figure that out. Open up a PR for this gem, and then it's like basically it's just like you're fighting it every step of the way. And so I was like really excited about engines. I thought they're an elegant solution, but they didn't deliver what I wanted. Then a couple months later, I went to a Boulder Ruby meetup, and somebody was talking about a new web framework called Lotus, which let you divide your project into apps from the very beginning. And later on, Lotus was renamed to Hanami, and now apps are called slices. And that was what drew me to the framework, was that this was like a first class feature in the framework. But I also learned that it had other differences to Rails. So one was that each action was its own class instead of your controllers having like their own, or each method in a controller being an action. It was its own class, which makes more sense to me. Because if you look at a controller, they really don't share that much across them. And then the ones that do share like params or views or whatever, there's better ways of that in Hanami that we do that. And also it doesn't use an active record pattern. So active record really it condenses all of your business logic and your persistence logic all into this one object, and then it ends up getting huge, and that's because it's trying to do too much. And so in Hanami, we have we use a repository pattern, which is your API to the database, and then there's a relation and struct, which we'll get to a little bit later. Yeah, and then also instead of managing okay, you have a record that you need to update, and then you're not sure if that has persisted to the database, if you've called save yet, right? Like when that happens, and if you call update attribute versus update column, there's all this complexity. And in Hanami, it's just immutable. So when you get the data back, you can't change it. And if you want to update the data, you call update, and then you get a new record back that has the updated values. Okay, so a brief history of Hanami. So it started in 2013, which was the router. And then in 2017, Hanami 1.0 was released. Then 2019, joined with DryRB and RomRB teams to build Hanami 2, which took a little while, but then Hanami 2 was released, which was basically a complete rewrite of the framework. And in 2024, 2.1 was released with a view layer. Later in 2024, 2.2 was released with a database layer. And then just last week or the week before, earlier this year, Hanami, Dry, and Rom merged to form Hanakai, as I mentioned. And then earlier this week, or maybe last week, last week, Hanami 2.3 beta was released. Okay, so this is what the architecture, the MVC diagram that I showed before, this is what it's like in Hanami instead. And so the data comes in here, and then I have this operation here, which is optional, and absolutely not every action will have an operation. It's just the more complicated actions have this intermediary object called operation that can help you manage some of, basically to let the action handle all the params and responses, and then all the business logic goes through the operation. And so as I said, the repo is the repository pattern, and the repo is what you call from the operation or the action. And then what the repo does is it calls a relation, which is your database table, your representation of your database table, and it gets that query and executes it, and then maps them to structs, which it then returns to the action. From there, I mean, you don't need the view layer at all. If you're running an API, I have an app where I have a serializer object I call, which is a plain old Ruby object. It just calls to hash, and it picks out from struct what we want, and it just sends it right out. But for applications that have a view layer, here's the view, and then there's a template, which is in Rails is called the view, but this view is a class in Rails, and then, or sorry, in Hanami. And then we have some other parts of the view layer, which are, you don't really, they're like optional for sure, but they're just like not used in every view. So the main one is a part, which is a presenter. So a part wraps a struct down here, and we'll see later that like a kind of canonical example would be like full name. If you had a record that had first name, middle name, last name, and you want to present it into the view, then you could just join these together, and it's just defined in that part for that user object. Helpers, which are very similar to Rails helpers, view helpers, just kind of like a quick and dirty way to like turn data into some markup. And then context and scope, which are what the template is rendered within. And so this lets us avoid having a context that's too big for the template, where it's like everything, you can access everything. The context really like scopes it down a little bit. Okay, so yeah, so we're gonna go through these gems. So this is Hanami with also Hanami CLI, and we'll talk about them together. So if you do Hanami new bookshelf, I think I'm gonna change it to, that's probably easier to see, is that right? Yeah, cool. So yeah, so I'm just gonna show you so if you do Hanami new bookshelf, and then go into bookshelf. So in app actions, you get, this is the module namespace for the actions. And then, womp womp. Okay, sweet. But yeah, so the same thing for views. This is pretty straightforward. You can see that these all match. And then, but notably, we do a nested style of modules rather than the inline style. You can definitely do inline style; it'll still work the same. This way, you just get that way you can use you could like reference things a little bit simpler instead of using the fully qualified name the whole time. So this is just an example of what that looks like. And then in your slice, so like I said, your slice is like a vertical slice of your application that's mountable. And then to show what the namespaces look like. So again, back here is when you do bookshelf, then everything goes into app. This is your main app, and then you get the bookshelf namespace. So the name is the same as your app. And then when you do a slice, it goes into slices / name of your slice. And then that gets the top level module for that. These are all the same, straightforward. And so app is a slice. It's just a special slice that handles configuration and other things like that. And the way you can access it is through hanami.app. If you're in the console, you can, in the Hanami console, which is similar to Rails console and IRB, you can just call app, and it will resolve to the same thing. And so slices are independently mountable, and they're also independently deployable, which is pretty big. As long as the dependencies are set up right, so you can have like slices that, if they don't use anything from each other, then they don't have to be deployed together. You can deploy them separately. And that's because each slice is its own container, which we'll talk about, and you can export and import components between containers. So containers help you manage your dependencies, and items in the container are called components. Each action, each view, each repo, each relation, each operation is a component. And then also each serializer, importer, exporter, whatever. Everything that you put in your app automatically becomes a component. And the way that those are identified is through its key, which is a string determined based on its class name. So this way, bookshelf actions books index is inside this bookshelf's container is actions books index. Pretty straightforward. An instance of it can be accessed via hanami.app, and then you pass like a hash, and it will give you an instance of this book's index. There's also configuration option to memoize these, so that way you actually, actions in Hanami are immutable, and so you actually can just have you could have one book's index in your whole app, and then every request will use that same instance instead of creating a new instance. And I'll show you how that works in a little bit. And then, yeah, just a little bit kind of low, I don't know if you can see it, but this this is an alias for app.container with this bracket. And so one thing to watch out for is that when you're in the console, again, you can just call app.boot, but let's do this for clarity, hanami.app. If you do hanami.app.keys, you'll just see these down here, which are the common, or not even all of these, I think, just I think inflector and settings are the only two that are included there. And then once you boot it, then you get to see the, then you can see these other actions, or sorry, these other components. And that's because they're lazy loaded, so they're created on demand for you. Yeah, and so these, this is how, so instead of, that's one way, instead of using core extensions, monkey patching to add inflections, we just have an inflector object, which is a dry inflector, and it works similar. You can define your own acronyms and all of that. And so you can import this into your, wherever you need to inflect a string, and then that way you are using an object and it's very straightforward. Logger, same thing, you get a logger, you can log to it. All your settings are accessible through settings, and then also routes is your routes path helper. So you like routes.path, and that's how you can access your routes. And again, instead of like adding like all these methods into the context, we have this like object that helps you. Okay, so now we're gonna dice up MVC. The first part's actions. So this is the API, which is that you have this one method called handle, and this is because an action can be called. You can send a call to it, which is rack compatible response, and this handle call just calls handle within it and kind of manages that for you. And so we're going to look at this. So this, and the reason why the reason why we can just use one instance of this index is because everything we need is here. We get a request in, then we set things in the response, and then that response is what's returned ultimately from the action. So you can call request.params, which are your URL query params, and then for index you wouldn't have form params, but if it was creator or something else, if you have form params, then they would be in there too. And then also request.m will give you the entire rack request m. And I just moved this so it can fit more on the screen. Yeah, like I said, we do the nested one. This is just inline for brevity. And then on the response, you can do response.status equals 200, which is the default. You can set headers like this, and then you set the body like this. It's pretty straightforward. And there's also some convenience helpers. So instead of status 200, you can also do status OK, and you can use the short names for them as symbols. And instead of doing content type equals text/HTML, you can just do HTML here. And then response.render view with an author ID, which we just did 1, 2, 3 here. And so here, this view isn't defined anywhere, right? And that's because basically what's happening is that because part of the glue between the action and the view is that a new view books index is created for this action. And of course, we don't want to do this because we have our container. So we use this. Use.books.index. And actually, this is such a common pattern, calling it like this, that we have a special deps, which is dependencies helper for dependency injection, which so this is the equivalent, more or less, to this. So this is a kind of weird syntax that looks strange at first, but then you get used to it. So what we're saying is that we want a new private method called view that is one of our views books index class components. And so this is the same thing. This is what's actually happening. This view comes from this, and it's just like because you assume that your index action is going to call your index view. So also this is another way is that you can pass responsive render. This author ID can be passed this way, but also you can also just set it as like a hash kind of thing here, which is called an input into the view, which we'll get to next. We'll not get to next. We'll get to it next. So this is validations, params and validations. So this is what's talking about the dry validation syntax. So it's required title filled string, optional published on is a date. That's all documented very well. And then down here too is some more of the APIs. You can use halt with a status code. Again, you can use the symbol if you want, and that will return immediately using a throw. And then yeah, down here, unless if the parameters are valid, then it will create this request params 2H. This book repo actually there should be an include depths book repo up here, and for this to work. Okay, now views. So if you pass an author ID in, and then you want to pass onto the template, you can just do author ID, straightforward. But it won't be passed otherwise. You have to manually tell it to pass it through. And then, but realistically, you're not going to want to pass. You probably don't want to pass the author ID to the view. You probably want to pass the author object. And so what we can do is you can expose the author, and then this is a kind of special thing that's it looks at the name of this this block from the input, from the action, and then you have access to that value. And yeah, again, we call author repo.find. And also, another example is it for books, right? So now we have books repo. This should be books. No, it's book repo. And yeah, so expose books and use the author ID and you find the books. And then the way you use these, so now we have author and books. And then in your template, you have author and books. So view parts, like I talked about, this is a way to wrap the struct, the data. And so the way you access the underlying data is through value. So now we call value.publish on the strip time, format the time, how you want. And then in here, you can just call it .formatted date. And so that way you can keep it as a method on an object rather than a helper. But we do have helpers. And these are, again, like I said, just kind of a more convenient way, or kind of a quick and dirty way to do something similar. So in this case, we have format count, reflector.pluralize. Yeah, then you just call format.count a method in there. Also view context, this is what I was talking about, where it gives you access to routes. So routes.path book, this is how you get a route helper. And reflector, the same things. You can call, so these, when you're inside a template, you can just call them directly. And then if you're in a part or a helper, then you have to call context stop just to get access to it. Okay, DB layer in 6 minutes. Let's see. Okay. So here, there's 3 different methods here. So one is this all. So this books is a relation that you have access to, which is your table, your books table. And then books by itself is a relation. It's not materialized. So this, you can call books.where or something, and it's still a relation. And then what you need to do is you need to call 2a on it, which turns it into, it executes the query, it turns it into the array. Similarly, if you want to do, if you want to get just one item for something, so this is by primary key. This is all from ROM SQL and ROM. If you call by BK, you still get a relation, and you have to call .1 on it, which is a new thing, obviously. But it's the same idea. So you just know that when you want to materialize something, you call 2a or 1, depending on what you want from it. There's also a 1 bang here. Well, not here, but there could be a bang here. And then if there's nothing in it, then it would raise an exception. And then so this is your book. Your repo is your app's database interface. It's how you access the database. And so here you also can create things with it. And so a very simple way would be just insert into the books table, right? So this is insert. This is a SQL insert. There's also commands, which kind of wrap some of this, and change sets as well, which you can look into. And they help manage association. So if you pass a struct in as the associated object, it will automatically associate the record. And so this is what relations looks like. So this schema, this is what tells it the books, that we're looking at the books table. And then we're telling it to use whatever the schema from the table is as this relations table. You can also manually define this if you want to. And that gives you some flexibility where you can create abstractions on top of your database table, so it doesn't need to match one-to-one. So if you have a users database table, you could have an auth users, which pulls the password out. But you could also have a profiles, which just pulls out the username from it, and some other information that's for the public. That way, there's less of a chance of leaking data out because it's all handled at the database layer. It's like they're like two different tables. And then it's also where you define associations in here, and also queries. So this reverse cron right here. So you call order, publish that. You can also put this into the repo. It's just a matter of trying to share the information. And so here, this is what this would look like, books.reverse cron. So this relation is the same thing that we were just looking at. So you call books.reverse cron, that way you add the order onto it and then you materialize it. And struct, so structure will come back from this. So this all returns an array of structs, find returns a single struct, create will probably return nothing because this is just an insert. That's also what the command does, is it will insert the record and then select it so that way you can get the data back. And so book.repo.find will give you a struct. Book.title gives you a book called the Learn Hanami display title, Learn Hanami 2026. And then if you try to set the title, the new title, you'll get a frozen error because it's not valid. So instead what you do is you call book.repo.update and then with a new title in there, and then it will update it and it'll give you a new book record that has the new title. Structs, these are optional, completely optional. So the struct will be defined automatically. But if you want to, you can define, you can use dry types to define these. And there's actually lots of options here that make it really nice. So this, I did type strict string. So if it's an integer for some reason, it will error out. But you can be more flexible. An example is this type's coercible date. So if this for some reason was like an ISO 8601 string, and it knew how to coerce it into a date properly, then it would just return date and it'd be fine. If it was type strict date, then it wouldn't be because it's not a date. It's not the right type. And then down here, display title. So this is what we use in our part too, right? Title published on year. And honestly, this, if it's only going to be used in the view, I would do it in a part. But if for some reason it needs to be lower in the stack, if you need to send it out to like a third-party service, an API or something, without going all the way into the view layer, then you could define it down here as well. Okay, quickly operations. So this is dry operation, which is our like interactor service object layer. So there's a special, the API here is that there's a step method, and then everything that step is called on, or that you call step on, has to return a success or a failure, which are part of dry monads. So you tell success, which means like, okay, keep going, and failure means like, okay, bail right now. So with this one, if the ISBN was already in the database and it was a duplicate, then this would just return a failure. And then if it's a success, then it'll keep going. In this case, we just say, okay, create this book repo success, so that way we have a success from this. In reality, you'd want to also check that this is correct, that like that the book got created, right? Because it's not guaranteed that you would get the book created. And then operations in the action. So if you include operations like this, you could call addBook.call with the params, and then you can use pattern matching, which is nice. So you do it in success book. So it returns the book from that operation, and then you have access to that book. And then if it's failure duplicate, which is what we called it before, then you get an error. I'm gonna skip testing, but it's really nice when you use dependency injection, you can stub things out very easily. Okay, so Hanami is Rack compatible. So you can mount Rails inside Hanami, and you can mount Hanami inside Rails. And this will let you experiment with trying out Hanami inside a Rails app and see how it goes. And also you can keep all your integration specs. And that way it's one less thing to write. And I think that's the move, is to try a little bit, see if it works, and then add more. I didn't really talk about it, but Hanami is much more memory efficient and faster than Rails. And so if you have like a hot route that you want to try it out on, that could be a good opportunity. Okay, so vibes in Hanami land right now. So we have a very like active, helpful community. There's like quick responses. We have a Discord and a Discord chat and discourse forum. And they're both like very active, and you can get lots of help there. And I looked at the some data in the discourse and GitHub and issues, and I did some sentiment analysis, and this is what the vibes are like right now. So this is like when we launched, and then there's kind of up and down, and then we're like right here right now, but I'm projecting Yeah, so join our growing community. We have active Discord and discourse. We don't tolerate Nazis, transphobes, racists, or any kind of bigotry. Yeah, so so you can hanami.rb.org is the main Hanami website, and you can look at guides on there, which is a separate site, and it's kind of wonky. Yeah, basically, like, this is where you can find all the information you need, also on GitHub. But we are creating a new website called Hanakai, and it's going to look very nice. And these are all messy, but it's going to be beautiful soon. So thank you. And do you have any questions? I don't have any no. For like when Hanami was like newer, I think there was like more of an emphasis in like the whole and ROM too as well. There was like emphasis on really like driving home the speed aspect of it. And then I think like, I don't know, like it just kind of like got lost in there. Like it is still much faster. It's just like less of like, I think that there's just like, basically there's nobody in the community right now who's like, okay, we need to like prove how fast it is. But yeah, like when I said the actions are going to be memoized, like we're going to do that soon. And I just did some benchmarks on that. And it like, even based on our own, it made it like 8 times faster to just like have one instance that you keep reusing instead of creating a new instance every time. You're still creating like the request and response instances per request, right? Like you're still creating objects, but just one fewer object, and like the coordination is all happening like at one spot. Yeah, it's a great question. So a couple things there is that you can't really do n+1s. Oh, sorry. So in our view class we queried from our view class, and in Rails generally you don't like to do that. And is it like less of an issue because we have a separation between action and view? And I would say like, yeah. So you definitely could make that query in your action if you want to, and then pass it through to the view. Like that's fine. I think it's I guess so. The thing I was going to say before is that n+1s are like not really an issue in ROM because of how it's like you need to build the query out yourself. So it does that data is not automatically loaded. So it just avoids that, which means you do have to write a little bit more for sure. But that's a benefit. And then I think the other thing is that there's it is pretty weird to put your queries in your view at first when you're used to the Rails way. But then once you like kind of break out of that, then like you're not going to be modifying data in the view, but you can query. Like there's no reason you can't, right? It's just like when you don't have to worry about the n+1s, then it's like, well, why not put it as close to where it's needed? And also there's there's a thing called the command query segregation, and so basically like your commands and your queries are separated, which like you can do in Hanami. We don't like make you do it, but like you can do it, and then that way you could have the queries which just like that we can only pull from queries in your views, and then your commands only happen in your actions. So that way like they're separated a little bit, and then when you do that, you also have some benefits of like being able to like separate you can have just like a read-only slice, right? Like a public, if you're just like a blog, for example, like if you just have a public blog, you're just reading stuff from like one server, and that's like a read-only replica database it could be, and then your admin is on a different server, and then that's where you actually do your commands and you update the data. And so that lets you scale that way too. Okay. Thank you.